Welcome to Study Loop.
We are given that t equals tangent of x over 2, and we'll go ahead and show these identities for cosine and sine in part A. So using this fact here, let's go ahead and draw a triangle. So for A, and then here this picture is kind of using the fact that we can draw something like this. So we need to use the fact that x is between negative pi and pi, and really I should come back over here. Our angle is x over 2. So the fact where this being used, this is negative pi over 2 less than x less than pi over 2. So we don't have x is not bigger than a right angle. Okay, so then if t equals tangent of x over 2, so we can also write that as tangent of this angle that we just drew equals t divided by 1. So tangent is opposite over adjacent, and then we could use the Pythagorean theorem to find the hypotenuse. Now we have all three sides, so we could find cosine and sine. So looking at cosine, this is just adjacent over hypotenuse. So we get 1 over the square root of t squared plus 1. So that's this formula up here. Check. Now for the second, sine. This is opposite over hypotenuse, so t over the square root of t squared plus 1. That's what the formula here says. So that verifies the second formula. So now we want to verify in part B these formulas for cosine x and sine x. So to do this, let's go ahead and use part A. So let me go to the next page here. So for part B, let's use the formulas that we just found in part A. 1 over t squared plus 1 in the radical. And then sine t over t squared plus 1 in the radical. So now, for example, if you want to find cosine of x, you could write this as cosine of 2 times x over 2. And then you could use your double angle formula for cosine. So cosine of 2y, for example, is cosine squared y minus sine squared y. So here we're using this formula, but with y equals x over 2. So this becomes cosine squared of x over 2 minus sine squared x over 2. And now using our formulas from part A, this is 1 over t squared plus 1, and that whole quantity is squared, minus sine of x over 2, and we'll also square this entire expression. And then we just go ahead and simplify. So we'll have 1 up top, minus t squared also on top. And then when we square that radical, we just get t squared plus 1. And that's the formula that they wanted for cosine of x. Now we'll go to the next page and we'll do the same thing for sine. 2 times x over 2. Now we'll use the fact sine of 2y could be written as 2 sine y cosine y. This is the double angle formula for sine. So using that here, with y is x over 2, we have 2 sine, there's our y, and then cosine y. Now using the formulas from part A, we found sine, and then for cosine, also from part A here, and then simplify that, combine those radicals. There's part B. Now let me go to the last page for part C. So recall the definition of t. Let's go ahead and take a differential on each side. And then by the chain rule, we have a 1/2 and then dx. I could also write this as 1 plus tan squared x over 2. This is by the Pythagorean identity. And just write that 2 in the denominator. Using t, the definition, this is 1 plus t squared over 2. And then just go ahead and take this equation here and solve for dx. And we have 2 over 1 plus t squared dt, and that verifies the formula for dx, and that's our answer.